The directions say to parameterize the lower half of the ellipsoid x squared plus 4y squared plus 9z squared equals 1. And that's good news. Life is easy. All you have to do is solve for z and take the right root and you'll have it. So the idea is this, and this is generic. Anytime you can describe a function as, say, z equals f of x, y, and it really doesn't have to be z equals f of x, y. It could be x equals f of y, z, or y equals f of x, z. The same trick will work if you use it right. But in this case, let's say you have z equals f of x, y, and you want to parameterize the surface. Then you could just call the first input u. That was supposed to be a different color. The second input v, and then z automatically becomes f of uv, and you get this vector valued function r of uv. If I use component form, I get that equals x, y, f of x, y, or u, v, f of uv. Now, it's not required that you actually make a substitution. You could really call it x, y, f of x, y, and I forgot my parentheses there. But that's what, so the first component u, second component v, third component, whatever the formula is, right? So, how do we get this in terms of just x and y then? Yeah. So we're going to get, okay, what do we get? We get 9z squared, first of all, is equal to 1 minus x squared minus 4y squared. Before we take a root, what should we do? Divide by 9. So I'm just going to divide the whole thing by 9. And then when we take the root, now which root do we want to take to get the lower half? Yeah, so it's not going to be a plus or minus, it's just going to be minus on the right side there. And just to clean it up a little bit, we get z then is equal to the opposite of the square root of 1 minus x squared minus 4y squared. And then, okay, always please remember that you can't split up the square root over addition or subtraction, but you can over division, right? And multiplication, but that's not relevant here. So you can write this as the square root of 1 minus x squared minus 4y squared over the square root of 9, which is just 3, right? Okay, so what's your vector valued function if you let x equal u and y equal v? So r of uv. Yeah, 1 minus u squared, square root, 1 minus, negative in front, square root, 1 minus u squared minus 4v squared. And then all over 3. Close that alligator bracket. Does that seem reasonable to you? Okay, that's it for that one.